Let's learn real analysis part 4. So today is all about size of things, comparisons, and absolute value. So absolute value solves this really great problem of knowing how close together two numbers are. For instance, if I gave you the numbers 3 and 5 and said what's the distance between them, you would know that you do 5 minus 3 and you get 2. And if you had done that in the opposite order, 3 minus 5, you would have gotten negative 2. Well, if you just take an absolute value at the end of that, you're always going to get distance. And that's why this quantity up here, absolute value of x minus y, is always going to measure the distance between x and y. This is probably the most important thing, the fact that we have a way of measuring distance. And actually, absolute value obeys a ton of really interesting properties. For instance, this thing up here is called the triangle inequality. We did a bunch of other stuff. We talked about number lines, drawing pictures representing, like, say, the distance between Ken and Barbie on a number line and how far apart they can be using absolute value and inequalities. The students took a quiz, and then we talked about upper bounds and lower bounds and what these mean. So we haven't yet defined actually what the real number system is, and the way that we're going to do it is by talking about upper bounds and how low they can actually be. That was kind of a mouthful, so let's explain what I mean. For instance, imagine I took all people on TikTok and I looked at their ages. Could I find an upper bound, or a number that's bigger than or equal to everyone's age? And I can definitely do that. I can just say 1 million. I know nobody on TikTok is more than 1 million years old. But the question is, could I do better than that? And of course, I could say like 1,000 years old. I know there's nobody on TikTok who's 1,000 years old. And if you ask me to keep going down, could I come all the way down and find the best upper bound? Or in other words, the lowest upper bound for that set? That would require a bit of spying on the TikTok database, but I could do that, and there is some number. It'd just be the age of the oldest user. Now, when things get more complicated and you just talk about, say, I don't know, the set of all rational numbers, such that when you square them and you get some number that's less than 2, well, that's some set of numbers. And could we find an upper bound? Well, yes, 1 million is still an upper bound, as is 100 or 1,000, or even the number 1.5. But if I then ask the question, well, what is the least upper bound? Is it a fraction? Is it a whole number? How do I describe it? Then we start getting to really interesting questions, and we realize that our axioms are not sufficient to answer this question. That's the mysterious topic for day 5, which is coming next, where we talk about the one missing axiom of the real number system.